Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with jointly weights and stationary process problem. Look at this problem. The random process x of t and y of t are defined by x of t equal to a cos omega t plus b sin omega t and y of t b cos omega t minus a sin omega t. Show that x of t and y of t are jointly weights and stationary if a and b are uncorrelated random variable with the mean 0 and the same variance and omega is a constant. Now first of all here what is given here, a, b are uncorrelated random variable with the mean 0. Therefore here given x of t a cos omega t b sin omega t and y of t b cos omega t minus a sin omega t, and then here a and b are uncorrelated random variable with the mean 0, where a and b are uncorrelated random variable with mean 0. Therefore mean value 0 means expectation of a 0, expectation of b 0. So when it's uncorrelated means covariance of a comma b 0. What is the covariance of a comma b? Expectation of ab minus expectation of a, expectation of b equal to 0. Here mean 0, therefore e of ab, this is a 0 into 0, 0. So a of ab, expectation of ab 0. And then same variance. So variance of a equal to variance of b sigma square. So when it's sigma square, variance of a, expectation of a square minus expectation of a whole square. Therefore variance sigma square, expectation of a square minus 0 square. Therefore expectation of a square equal to sigma square. Similarly variance of b equal to expectation of b square minus expectation of b whole square. Substitute variance of b sigma square and expectation of b square minus 0 square, expectation of b square equal to sigma square. So from given condition, what is the value we know here? So expectation of a 0, expectation of b 0, expectation of ab 0, and then expectation of a square equal to expectation of b square equal to sigma square. So this is a value, we know that. Fine. Now so what is the question? Still now what are the values are given, so we can mention here. Now x of t, y of t are jointly weights and stationary process. Therefore jointly weights and stationary process is nothing but first condition, x of t WSS process. To prove x of t WSS process, first one, to prove x of t is WSS, weights and stationary process, and then second, to prove y of t is weights and stationary process, and third, to prove cross correlation or xy of tau is a function of tau. These three conditions satisfied, then it's a WSS process. The first one, if you want to prove here, two conditions. One is expectation of x of t constant, and then second condition or xx of tau a function of tau. Here also two conditions. One is expectation of y of t constant, and then or yy of tau function of tau. So this is the only we are going to prove. So first one, to prove x of t is WSS. How to prove? Two condition. One is expectation of x of t equal to constant. Expectation of x of t equal to a constant, and the second condition or xx of tau autocorrelation function a function of tau. Function of tau. So now the first one is expectation of x of t is nothing but expectation of x of t value a cos omega t plus b sin omega t. Now here a and b are random variable, therefore cos omega t constant, expectation of a plus sin omega t constant, expectation of b. Now expectation of a value 0 and then expectation of b value 0, therefore 0 into any term 0, 0, 0 a constant. Expectation of x of t constant, the first condition satisfied. And then second condition or xx of tau equal to expectation of x of t plus tau. So expectation of x of t is nothing but a cos omega t b sin omega t, and then t plus tau, replace t where t plus tau. So a cos omega t plus omega tau plus b sin omega t plus omega tau. Now to multiply this term, expectation of first term into first term, a into a square cos omega t plus omega tau. So the first term multiply with the first term into first term, and then first term into second term. So plus ab into cos omega t sin omega t omega tau. Then second term into first term, this second term into first term, therefore a b into a, so ab sin omega t cos omega t plus omega tau plus b into b square sin omega t plus omega tau. Now take expectation for the individual term. Now a b random variable, therefore cos omega t plus omega tau constant for this term. Now expectation of a square plus here also this is a constant, therefore cos omega t sin omega t plus omega tau expectation of ab, then plus here also this is a constant, this term full constant, sin omega t cos omega t plus omega tau expectation of ab, plus this term again full constant sin omega t sin omega t plus omega tau a of b square. Now this term for AB, this AB value 0, this value 0, and a square and b square equal. Therefore cos omega t plus omega tau sigma square plus 0 plus 0 plus sigma square. So sin omega t plus omega tau sigma square. When I am taking sigma square common, cos omega t omega tau plus sin omega t plus omega tau. This is a value. Look at here, cos A cos B sin A sin B is nothing but cos A minus B, cos A minus B. Therefore sigma square cos A value, this is a cos A cos B, cos A value omega t minus omega t minus omega tau. These two term cancel. Sigma square cos of minus omega tau, and then cos of minus x is cos x, sigma square cos omega tau, it's function of tau. So this is a r xx of tau. Now this two condition, first condition x of t constant or xx of tau function of tau, therefore x of t is a WSS process, wide sense stationary process. And then to prove second one, to prove y of t is a WSS process. If you want to prove this condition, first one, expectation of y of t constant, and then second condition or y of tau a function of tau. Now the first condition, expectation of y of t equal to expectation of y of t value b cos omega t minus a sin omega t. Here a b are random variable, therefore expectation of b cos omega t, expectation of a sin omega t, expectation of a value 0, this is a 0, and a b value 0, therefore 0 minus 0 0 constant. Expectation of y of t constant. So first condition satisfied. And then second condition, or y of tau equal to expectation of y of t plus tau. Now b cos omega t minus a sin omega t, this is the y of t, and y of t plus tau to replace where t, to replace t plus tau. So b cos omega t plus omega tau minus a sin omega t plus omega tau. Now multiply with each and every term, b into b, b square, cos omega t plus omega tau, then b into a minus ba cos omega t sin omega t plus omega tau, then second term into first term minus ab sin omega t cos omega t omega tau, minus minus plus a square sin omega t plus omega tau. Now take expectation of the variable. Here this is a constant, these terms are constant. Variable AB only variable, therefore expectation of B square cos omega t plus omega tau minus expectation of AB cos omega t sin omega t plus omega tau minus expectation of AB sin omega t cos omega t plus omega tau plus expectation of A square sin omega t plus omega tau. For this term AB value 0 and these terms are equal. So this is a AB square, expectation of A square B square equal. This value sigma square, this is a sigma square. Therefore sigma square cos omega t plus omega tau minus 0 plus sigma square sin omega t plus omega tau. Now when I am taking sigma square common out, sigma square cos omega t plus omega tau plus sin omega t plus omega tau. Now as usual cos A cos B. So cos A cos B is nothing but cos of A minus B. Therefore sigma square cos A minus B. To cancel this two term, sigma square cos of omega tau is cos omega tau. This is a function of tau. So this is a Ry of tau, Ryy of tau, a function of tau. Therefore y of t is a WSS process. So the first one x of t WSS process, then y of t WSS process, and then the third one is cross correlation function, cross correlation function of x of t and y of t, function of x of t and y of t. Now Rxy of tau equal to expectation of x of t y of t plus tau. Now substitute x of t value x of, here A cos omega t plus B sin omega t, this is the x of t value. Y of t plus tau B cos omega t plus omega tau minus A sin omega t plus omega tau. Now to multiply with each and every term. So when I multiply expectation of A into AB cos omega t plus omega tau, then first term into second term minus A square cos omega t sin omega t plus omega tau, then second term into first term B square sin omega t cos omega t plus omega tau minus BA sin omega t plus omega tau plus omega tau. So now taking expectation, these terms are constant, this term and these terms are constant because of a b only variable. Therefore expectation of a b cos omega t plus omega tau minus expectation of a square cos omega t sin omega t plus omega tau plus expectation of b square sin omega t cos omega t plus omega tau minus expectation of a b sin omega t plus omega tau. Here expectation of a b a square a b b square. So this value 0, this is a sigma square, this is a sigma square 0. Now substitute this value, first term 0 minus sigma square cos omega t sin omega t plus omega tau, then plus sigma square sin omega t cos omega t plus omega tau, then minus 0. When I am taking sigma square common, sin omega t cos omega t plus omega tau minus, I am taking first second term, then minus cos omega t sin omega t plus omega tau. For this formula, sin a cos b minus cos a sin b is nothing but sin of a minus b, sin a cos b minus cos a sin b. So here sigma square sin a minus b, these two terms cancel. Therefore sigma square sin of minus omega tau. So sin of minus x is nothing but sin of minus x is minus sin x. Therefore minus sigma square sin omega tau. So this is a function of tau or xy of tau. So therefore here x of t and y of t are jointly WSS process. Thank you.